Well, welcome to ATMOS 2750, day number 14. We're starting to focus in on the different types of electrical generation systems, and in order to do that, we have to understand where the fuels come from. So we're going to talk a little bit about the different types of fossil fuels that are available for power generation. We'll look at specifically at where coal comes from, where petroleum comes from, where natural gas comes from, and then we'll talk about an alternative type of hydrocarbon, which is oil shale or tar sands. And then we'll look at where Utah actually gets its electricity from, and we'll specifically look at how a coal-fired power plant operates, and look and see how that compares to natural gas-fired power plant and nuclear power plant and that sort of thing. So if we think of fossil fuels for energy production, we're literally looking at hydrocarbons, which can broadly be broken out into coal, natural gas, petroleum, and alternatives such as oil shale and tar sands. So coal primarily formed during the late Paleozoic era, which is known as the Carboniferous period, which was right around a little bit more than 300 million years ago. And during that time period, the carbon dioxide concentrations were high, the oxygen concentrations in the atmosphere were high, the planet was warm, things were growing quickly, things were growing to large sizes, and there may or may not have been bacteria capable of basically causing the decay or the recycling of plant material. And over time, this plant material would build up on the forest floor or in the swamps and would get buried. And when it's initially buried, it starts to build up. We refer to that as peat. But then as it gets buried and gets compressed under the weight of the overlying soils, it gets compressed, the water gets squeezed out, and then if it gets buried deep enough, then it starts to warm up due to natural radioactivity of the Earth's core. And that can cause chemical transformations, which transform this carbon material into carbon rock known as coal. And coal has the ability to actually ignite and to burn because it has a very high carbon content. And the Carboniferous period was such a important growth period for plants on the planet that it was actually removing carbon dioxide from the atmosphere and storing it in the ground. And it did that so effectively that it eventually removed enough carbon dioxide from the atmosphere that the Earth went into a prolonged period of almost total glaciation. Afterwards, it basically almost turned us into a snowball Earth because it removed so much carbon dioxide from the atmosphere. So these hydrocarbons, specifically the coal, is being mined in the United States. The most abundant mines were in the Appalachian regions and in Pennsylvania. But there are significant coal mines in the West, primarily in central Utah and in Wyoming. Wyoming has the advantage of having a very low sulfur-based coal, which makes it clean burning compared to a lot of the coal in Appalachia. Natural gas is also a hydrocarbon, and it forms in much the same way as coal. So you have, and natural gas is composed primarily of methane, which is the simplest of the organic gases. It's typically about 70% methane and 30% slightly heavier hydrocarbons, ethane, butane, etc. And the natural gas is found deep underground, and it's associated with hydrocarbon reservoirs, typically coal seams and oil. Basically, as the carbon material is decomposing and transforming, one of the products of that transformation process is actually natural gas. In order, however, to accumulate natural gas in the ground, you need to have impermeable rock structures that can trap it. Otherwise, the gas will eventually make its way to the surface and escape to the atmosphere. And when we talk a lot about oil exploration and drilling will specifically look at the different types of rock formations that can trap oil and gas. So petroleum is basically another word for the oil-based products, which are another hydrocarbon reservoir. So unlike the coal, which was formed on land, the petroleum was formed in shallow seas. So millions of years ago, we had algae and plants that lived in these shallow seas, and when they died, they went to the bottom and were incorporated into the sediment. These sediments were buried over time, and as the pressure increased and the temperature increased, these organic materials were gradually cooked and transformed into natural gas and petroleum. So the main difference between coal and oil and petroleum is that the coal was formed on land and the oil and petroleum was formed in shallow seas. And so where do we find that petroleum today? Well, we find it in vast underground reservoirs where ancient seas were located. So as plate tectonics have moved the continents around and there's been uplift, some of these areas that were the bottom of seas before are now above sea level. So a lot of the oil and gas is located on land now, and there's still a significant amount of oil and gas on the continental shelves, which were part of the shallow seas before, that are still covered in water. So here we can see the location of the oil and gas wells in the United States in 2017. The red are natural gas wells, and the green are oil, and yellow is kind of a combination of the two. And you can see that the areas that basically have oil also tend to have gas around the periphery of those sorts of things as well. And that's true here in Utah. We have gas wells and oil wells over in the Uinta Basin. There's also gas wells in Wyoming. And why are a lot of these reservoirs located in like Texas, Oklahoma, Kansas sort of thing? Because that was a shallow sea. Before the uplift of the Rocky Mountains, there was a sea. The Gulf of Mexico extended up into the central part of the U.S. I grew up in Kansas, and I can attest to the fact that the fossils on the surface in Kansas are actually of coral and seashells and that sort of thing. So there's other types of hydrocarbon reservoirs that we do need to talk about because of their proximity to Utah and the environmental impacts. And one of those is oil shale. Oil shale is a sedimentary rock that contains kerogen, which is a solid mixture of organic chemical compounds. And it's if you work at it really hard, you can convert this oil shale into liquid hydrocarbons that we refer to as shale oil. So the way I think of oil shale is basically it's oil that is in the process of being created by Mother Nature, but it still needs millions of years of cooking in the ground to properly turn itself into a petroleum product. But through the marvels of technology, we can accelerate that process by heating the rock and treating it with chemicals, and can actually leach out a hydrocarbon, a liquid hydrocarbon that has a lot of the same properties as oil. Tar sands are similar in that it's basically we have sand particles that are loosely consolidated, and they contain sand, clay, water, and it's soaked with bitumen. And bitumen is a dense and extremely viscous form of petroleum, not too different from asphalt, if you can imagine that. And the oil shale and the tar sands are a substitute for conventional crude oil, but extracting them is extremely difficult. It costs a lot of money with using most technologies, and it does a lot of damage to the environment. A lot of times these oil shale and tar sands are accessed by strip mining, which is removing the top layers and then getting access to it. And then it involves heating the subsurface, and that takes a lot of energy. And they need to spread that heat around and by injecting hot water into these reservoirs. And so it takes a fair bit of water too, and the water that comes out has been contaminated with these chemicals and the petroleum products. So where's oil shale reserves located? Well, the reason it's relevant to this class is because there's a really large oil shale reservoir in the Uinta Basin in Utah. This is also coincident with the oil and gas areas that are currently being drilled and producing oil and gas here in Utah. There's also significant oil shale reserves in western Wyoming and western Colorado. If we look at tar sands are primarily in Canada, in the province of Alberta. We have very large area where we refer to those as the Athabascan oil sands. And Canada has been mining this oil sands for at least 20 years. They have massive strip mines where they've moved the earth back to get access to these and are using heated water and other treatments to extract the oil-based products. Now, the one thing that you have to keep in mind is that this area is drained by the Athabasca River, and the Athabasca River flows north. So any contamination that makes it into the waterways in Alberta will actually head north and will end up in the Arctic, which is a particularly sensitive ecosystem. So let's take a look at the electricity generation in Utah. So currently, 2/3 of the electricity in Utah is being generated by coal combustion in the coal-fired power plants that we have in the state. 25% of our electricity production is occurring through natural gas combustion in power plants, and only 9% is being generated by renewables. In our state, it's a mix of wind, solar, and a little bit of geothermal. But solar is the one that's growing the fastest here in Utah. So where are these coal-fired power plants located in Utah? Well, most of these are located at areas near to the coal mines so that they don't have to transport the coal very far before they combust it. This lists one coal-fired power plant in the Salt Lake Valley, and that's no longer the case. That was converted to natural gas, and then it's being phased out now in favor of renewable energy purchases from wind power in Wyoming. So we have very large power stations here that are primarily using coal. As I said, the Kennecott Utah Copper Corporation was converted to natural gas in 2018, and now it's being phased out entirely. And the Intermountain Power Station, that's the one near Delta, which is the one to the furthest southwest, is the largest power plant in the state, and it's going to be converted to a natural gas fired power plant in 2025. So how does a coal-fired power plant actually work? So in order to do this, I think that there's a really good YouTube video that I encourage you to watch that will walk you through the individual processes of the coal generation of electricity, and specifically pay close attention to how water is used in this process. There are two types of water that are used. One is basically water that's recycled and reused, and then there is water that is used for cooling purposes, and that must be pulled from a water source, typically a river, and then it will cool the steam, condense it back down into liquid water, absorb that heat, and then be liberated and put back into the water body from which it came. So we do have some natural gas power plants in Utah. They are primarily located along the I-15 corridor. And the reason for this is that there is a very large natural gas pipeline that leads from the gas fields in Wyoming all the way down to Las Vegas. And it basically follows the I-80 and then I-15 corridor. And so if you're going to put a power plant in Utah, you need to put it at a place where you have ready access to the natural gas, and that pipeline is one of those places where you can get access to the gas.